All right, people at home, you have missed some stuff that we've talked about in the classroom. So what I want to talk to you about really quickly is a formula that we can use when we're starting to solve some of these problems about the mole. Now, the formula I'm going to show you works when we're converting grams to moles or atoms and molecules to moles. And you don't know how to do the second part yet, but today we're going to talk about converting grams to moles. And this is the formula. This is what it looks like. The number you are given over 1 times 1 over the proper number. This much of our equation that will eventually get bigger will equal to the number of moles that you have. Okay? So you should write this down if you're at home, because we've already written this down. People are in the room. The number you're given over 1 times 1 over the proper number equals the number of moles that you have, okay? Now what we're talking about here is when you have a certain amount of metal, you can weigh it and then determine how many moles of the metal you have. If you have a certain amount of powder, like a compound that's in powder form, you can pour it onto a scale, weigh it, and then determine the number of moles of that powder you have, moles of that formula. So we're going to use this formula right here on our worksheet. Number one says we have, I'll tell you what, let's skip on down. We've already talked about the first 4 or 5 in here, so kids at home, we're going to skip to number 5, all right? Number 5 on this sheet. You have 987 grams of radium hydroxide, okay? So you have the number you are given is 987 grams, all right? So now we need right here, we need the proper number in grams for radium hydroxide. See, the number here, if this number is in grams, then this number right here needs to be in grams, the proper number. The formula for radium hydroxide is RaOH2. I'm almost positive that was probably supposed to be barium hydroxide, but what the heck? We look on the periodic table, okay? If you look right here on the periodic table, you'll see that radium has a weight of 226. Oxygen is 16, hydrogen is 1. So let's calculate the mass of radium hydroxide, all right? This is 226 grams, and this is going to be 16 plus 1, or in other words, 17 times 2. So 226 plus 17 times 2 is equal to 260 grams. Is that right, kids in here? Did I do my math right? Radium hydroxide, 260 grams? Okay. So, if you have 987 grams of radium hydroxide, then the proper number for radium hydroxide is 260 grams. This is what you're given. This is what that formula actually weighs by looking at the periodic table. And kids in here, Carlos, what'd you get for that? We'll just call it 3.8. We'll just go 1 decimal point to make it easy. All right, does this make sense, kids at home? All right, let's do one more. Let's do one more from this worksheet. Let's do number 6. Number 6. All right? Number 6. Number 6 says you have 564 grams of copper. So the number we're given, the given number, is 564 grams. And now we need the proper number, all right? Well, luckily, the formula for copper is just Cu. So copper on the periodic table, if we go up here and we take a look at it, we'll see that copper is 63.5. And you can put 64. I'm not worried about you being perfectly precise yet till we just know how to do this. I'm going to go ahead and put 63.5. So we look right over here. We're filling our formula out. You have 564 grams of copper on your scale. 1 mole of copper would only weigh 63.5 grams. So how many moles do you have? You have almost 9. Ashley, what's the answer? 8.8 moles. There we go. So that's how you do it. The proper number, the number you're given times 1 over the proper number equals how many moles you have. Now, on the other side of this worksheet, we're basically doing the problem backwards. Let's flip back to the other side of the worksheet, and let's all take a look at number 10, okay? Number 10. These problems are much easier. These problems are converting moles to grams. Number 10 says, this is number 10 we're working on. Number 10 says we have 5.6 moles of C6H6 of C6H6. That's a pretty terrible looking C. That one even bothers me. There we go. We have 5.6 moles of this. Now, these are very easy. We ask ourselves, how much would 1 mole of this weigh? Okay, this part of the equation, carbon weighs 12, and you have 6 carbons. So that's 6 times 12, 72 grams. Plus, you have 6 hydrogens. Every hydrogen weighs 1, right? So 6 times 1 is 6 grams. So this would be 78 grams per 1 mole, right? But you don't have 1 mole. You have 5.6 moles of it. So very simply, instead of dividing like we did on the other side of the worksheet, we have 5.6 moles. Watch this. 5.6 moles. All right? How much does 1 mole weigh of C6H6? 1 mole weighs 78 grams. So that's all there is to it. Did anybody do that one? Evan, what'd you get? 5.6 times 78? 436? 436.8 grams. That looks right to me. Does that make sense to everybody? And let's just try number 11 just for the heck of it. Number 11. You have 21.3 moles of barium carbonate. How much would that weigh? All right, let's figure out how much barium carbonate would weigh. Barium itself has a mass of 137. That carbon right there weighs 12, and 3 oxygens would weigh 48. I just did 16 times 3 for those of you at home. Okay? 137 plus 12 is 149. 149 plus 48 is, what's that, 197? 197 grams. So, if we have 21.3 moles of barium carbonate, then we have 21.3 moles. How much does a mole weigh? 21.3 times 197. Really simple. It's going to be approaching 2,000. What'd you get, Gabby? I mean, not approaching 2,000.
4,196.
Yeah. Approaching 4,000. 4,196 grams. Okay. And that's it. People at home, that's your help with this worksheet. And at home and people in here, there's going to be an ed puzzle today that works us through this more slowly. Okay? All right.